Have you ever seen a computer with an IP address in the range that is not in the private address ranges that we learned about in Networking 101? But yet, it's not a public IP address. So what's going on with this address? Thanks to my buddy Joe, in this video, we will look at what automatic private IP addressing is, why it happens, and how you can tell it's happening. We will also use Wireshark to take a look at what the packets look like when they are going across the network. In a normal network, all devices on that network are assigned an IP address before it can communicate with other devices on that network and other networks. Usually, this is done by using the DHCP, or the Dynamic Host Configuration Protocol. When a computer joins the network, it will send out a request onto the network looking for a DHCP server, which will then respond and assign it with a unique IP address for that network. But what happens when the DHCP server is not reachable because the network connection is severed, or if the DHCP server is down? In this situation, the computer, especially Microsoft Windows machines, will self-assign an IP4 address in the range between 169.254.0.1 to 169.254.255.254. The IPv6 address range of FE80:10 has been reserved for APIPA. This is also known as the link local address. The link local IP addresses will be assigned pseudo-randomly by each device itself, and because of the collision possibilities beyond its own network segment, routers do not forward packets with link local source or destination addresses. Alright, so how can you tell if your machine has an automatically assigned private IP address? Well, it's easy. If your IPv4 address is in the range between 169.254.0.1 to 169.254.255.254, and you didn't set that as your static IP. To verify that Windows was the one that did the IP assignment, we can bring up a command prompt window and then type ipconfig. If we scroll back up, and we can see here for the interface named Ethernet, we have an IPv6 address that is labeled link local, and it starts off with hex FE80. So that tells us that the IPv6 address is self-assigned. In the next line, we see that the IPv4 address is labeled auto configuration. And then the IP address itself is 169.254.44.153. And this definitely starts with 169.254, and it's got a subnet mask of 255.255.0.0. So that tells us that the IPv4 address is self-assigned as well. And lastly, we see that there is no default gateway assigned, and that tells us that this range of addresses is not routable. So all these factors come together and give us a pretty good clue that this is a APIPA in action. And we can also verify that we are still using DHCP by looking at our network connections, and then the Ethernet status, and then properties, and then looking specifically at the IPv4. So here you can tell that DHCP is still selected. And to see the behind the scenes of how this works on the network, I launched Wireshark to monitor the Ethernet network interface. We see traffic from our own machine, which is 169.255.44.153. And it starts with an ARP probe broadcast going out to the network. It does this 3 times in an interval of 1 second apart. And then when it hears nothing back, it does a ARP announcement when no one else on the network answers up with that IP address. Then subsequently, we see that the other device on the network, which is our iOmega NAS, sent out a ARP request to see who is 169.254.44.153. to which my computer responds with its MAC address in an ARP reply. And later we see my computer sending out an ARP request for 169.254.133.94, which is the I omega NAS. And then the I omega NAS responds with its MAC address in an ARP reply. Now that everyone on this local network with a non-responding DHCP server has self-assigned themselves IP addresses, they can communicate with each other, but remember, not with another network, right? As their addresses are not routable. Another thing to keep in mind is that the devices that have a automatically assigned private IP address may have a different IP address reassigned once the DHCP server comes back online, or if the device is rebooted and it has to go through the automatic private IP address process again to obtain a fresh IP address. And about every 3 minutes, or whenever the network interface senses a change, the automatic private IP address service checks for the presence of a DHCP server. And if it sees one, then the IP address assigned by the DHCP server will replace that of the auto-assigned IP. Now that you know what it means when you see addresses in the range of 169.254.something else, you've got some DHCP server issues that you should hunt down, unless you see the address of 169.254.169.254, in which case it's a cloud thing that Amazon and Microsoft virtual machines use that specific address to access particular metadata. Oh, Microsoft. For more networking nuggets, watch this video here. Be sure to make comments below and make sure you click on the blue monkey to subscribe. Thanks for your time and happy hunting.